All right, welcome to another episode of the Base-12 Book Club. This is episode number 8, and in this video I'm going to give an overview of the book, what its contents are, and this video is designed for people who don't have the book. Most of the videos up to this point have been for people who've already bought the book, and we're just going through chapter by chapter, explaining the difference between Base 10 and Base 12, and really acknowledging the fact that we have to work using Base 12 mathematics. And then I introduced the geometric shape that we're going to be building the diagram for. And essentially the book is about labeling the steps or numbering the steps that you need to go through to create a diagram that generates 360 points on the circumference of a circle. So it's quite a large diagram. You can see what it looks like here. And if you think about it, 360 points are a lot of individual points on the circumference of a circle. So it's a process of drawing larger and larger circles and using the geometry from the sort of inner rings to radiate the lines outwards and then build on those as you go farther and farther out. So we start with the seed of life diagram or the tube torus diagram, and then we just keep building the diagram until we get to the point of 360 degrees. So in that process, what we're doing is we're taking a solid line of the diameter of a specifically dimensioned circle, and then we're dividing it into the circumference. We're placing it on a polygon that is created by using the geometry contained within this dodecagon pattern. So we start with a very small 12-sided dodecagon, and then we start to progress to larger versions of that same dodecagon. So we have the proportions of the perimeter of that dodecagon, and what we do is we work with that geometry and we convert it into a polygon. So it has more sides than just 12, but it has exactly the same length of perimeter, and it's perfectly balanced. And we get it so that although we start with a dodecagon that has equal sides, but not all of the points are the same distance from the center, and we're able to work with it when we get to a larger version where we can manipulate the proportions a little bit and we can create a polygon where all of the points that define that dodecagon are equidistant from the center. And once we've done that, we use those points to anchor circles that are generated from the diameter of the dodecagon. We just basically place them on the perimeter. So now we have points that are all equidistant from the center of the circle or the polygon, whichever you want to call it. We're sort of saying it's a polygon, but it can also be defined as a circle where we have points that are all equidistant from the center. And then we can just keep building on the geometry that comes before, building larger and larger versions of the polygon, placing the diameter of the dodecagon onto its circumference. And when we do that, the trick is, or the geometry that's revealed is we do so in such a way that there's an empty space between all the individual units of diameter. So this is the real sort of revolutionary idea, is that what we're doing is we're dispersing that empty space throughout the circumference of the circle instead of just having a solid circumference with a little gap at the end. And often when I talk to mathematicians and I mention this little gap, they sort of look a little bit quizzical and say, what empty space, what little gap? So the gap I'm referring to is the one where all those decimal places are going. The fact that these irrational numbers like pi keep going on forever is because there's always a little bit of empty space or a gap, and so we have room for more decimal places, more bits of that diameter, and that goes on forever. So that's our current model. Although it's never really been stated as such, that's the model that we have of pi and all irrational numbers, really, a solid line with a little gap at the end. And so in this model, we're taking that idea and we're changing it up a little bit, and we're dispersing that empty space throughout the circumference of the circle, and then we build larger and larger rings of the diagram, and each ring has the same proportions. The distance, and here's the unit of circumference that we use to build the circle. The distance between these two sections of diameter is the same for every ring of the diagram. And so the structure of the diagram is such that this circle, this one unit, is the one that's sitting on the circumference of the circle that we're working with. And these units of the diameter are always just a little bit out. They're always just a little bit outside. But the distance between those two separate circles gets narrower and narrower as the diagram gets larger and larger. And so we get to the point where we've drawn the diagram for 360 degrees. All of the points are perfectly delineated. There's an equal space between them. And at that point, we realize we can keep going. We can keep dividing the circle into smaller and smaller sections, the circumference of the circle into smaller and smaller sections, and we continue this process of growing the circle. And then we realize we can do it sort of exponentially, and we eventually, in the later chapters of the book, I go through the process of growing the circle from what you see here, which is basically, sort of measuring in feet and meters, about 60 feet in diameter. And we just use our imagination to imagine a circle that grows to the size of our universe. And we kind of follow that journey mathematically, and we sort of imagine what that looks like. So we have a huge circle where that little section of circumference becomes essentially a straight line, and we imagine, what does that look like? So when we get to that point, we have a row of these circles, we can rotate them this way or that way, that are in a straight line, and the circle, our large circle that's the size of the universe, can pass between the space between these two units of the diameter. And once we get to that point, we realize that actually we can separate these a little bit more and create more space, and we end up with an environment where there's a lot of empty space, and we have this geometric pattern just kind of floating in space, so to speak. And that's where we end up, and we realize that this is a significant geometric pattern. This is the relationship, or creates a relationship between the two aspects. Ultimately, we're talking about the physical universe. And so this is where I'm suggesting that this mathematical pattern actually emerges from the geometry of the universe and not the other way around. We're not taking a sort of a mathematical idea that's just sort of something we make up in our heads and apply it to the universe, but that this is actually the math that emerges from a structure that already exists. So this geometric pattern is something that already exists within the fabric of space-time, that really small quantum area where we have quantum units, individual little units that are floating in empty space, and from that we eventually build up to the solid world that we have around us. So that's a long journey. And so just to go back again to the geometry that we're working with, because we have a perimeter of a dodecagon, we have a fixed length right there, and we have a fixed diameter right there. So we have a diameter, we have a perimeter that ultimately becomes the circumference of a circle. So it's very easy to do that equation of dividing the diameter into the perimeter of the dodecagon, which ultimately becomes the circumference of the circle. And when we do that using square roots, because we're working with units of square root of 2 to build this diagram, so when we keep it in square roots and we divide, it works out, I believe, square root of 5.02 into the square root of 42, we get a number that's a square root, starts with a 9, and then in base 12 it goes 9.B8017191, and that number continues along for 96 digits in base 12, and then it repeats again. So the initial impulse, because we're so used to the base 10 version of pi, is to say, well, that's obviously not pi because it doesn't have the same characteristics. It stops, and it feels in a way in a short length, and then starts to repeat again, and it's a square root, and it, but at the same time, we've just used this geometry to create a huge circle where we can plot all those individual points. So we start off, the very first ring of the diagram for 360 degrees generates 24 points in base 10. So that's 2 do, or it looks like 20 in base 12. And then we can, when we go through the process of growing the circle exponentially, we realize that the last ring of the diagram, we get a number that looks like 10 to the 96th, but in base 10, That's the base 12 number. So in base 10, that's actually 12 to the 114th. So that's a number that's larger than a googol, which is 10 to 100. So we have that many points, actually times 2, because that's in 12s and the rings are in 24s. So that's a lot of individual points around the circumference of a circle. So I'm sort of challenging the definition of a circle, that it's an infinite amount of dimensionless points. And I'm saying it's this many points and they have a dimension. There's a structure that generates those points, and it's possible to generate them all. If you have a computer and you go through the process, you can generate that many points on the circumference of a given circle. That, to me, is the perfect circle. And so that's what I'm introducing in this book. And I don't even think I did it as well as I just said it. I don't have all those numbers in the book because it's okay. The geometry is there to get us to that point. If you're watching this and you already have the book, you'll say, where does he talk about that 10? I introduced a very big number because that number actually is larger, ends up being larger. If you start at the Planck length and go all the way to what we consider to be the known universe, or the size of the universe that we can see, we don't have to use all those digits. We only get to about 60 or 70, I believe, and we still have another 20 to go. So even though it may seem that this version of pi is kind of short compared to the base 10 version that has trillions of digits, I think we all realize that those trillions of digits are essentially meaningless. Nobody's using or needs that many digits of pi to make any sort of calculation, to use that number to, navigate either the universe, the outer universe, or the inner universe of the quantum. So that's the big deal with this whole thing. So this is a physics event where we realize that there is a math that gives us a structure. There's a geometric pattern that gives us a structure where we can explore the idea that this actually represents something. And I believe it actually represents a torus, that we're looking at like sort of a side view of a donut shape, where these are the two rings of the donut and their space. So this would be sort of spinning around, and it's actually two balls of energy that are spinning and interacting and generating waves, and that they're spaced in a grid-like pattern at the very base of physical structure. So you can also say that that's the base of mathematics. So we have a quantum size, and the radius of these circles is 0.49 in base 12, 0.49 root 2, and the space around the edge is 0.03 root 2. When you add those together, you get 0.5 root 2, and that length of 0.5 root 2 becomes the base length that we build a new grid pattern, or a Cartesian plane in a way, that encompasses both these qualities. There's like two separate elements. The lines of the grid have a thickness, and the squares, and they have a definite relationship to each other. There's a ratio between those two sides, and this is what that looks like. This is basically the end of the book. We get to a point where I say this is where this geometry leads us. Okay, so that's the starting point if we want to map out the quantum universe and then join it to the macro universe. So that's why this book's important. I believe this is the mathematics that will lead us to be able to join the quantum with this, I guess, standard model, or the larger universe with the very small. Link these two things together, because this is what we've been trying to do in physics, and I think this is where the challenge lies. So this is the start. This is the introduction to the geometry that I believe is going to be able to solve that problem, or to unite these two aspects. It has to be done in base 12. That ratio doesn't line up the same in base 10. Okay, so I think that's enough for that video. I wanted just to give you an overview of why I believe this is important. This video is for anybody who hasn't bought the book. So again, here's what the book looks like. It's available on Amazon. You can get it there. It's not too expensive, and it will introduce you to that number. I'm going to add one more thing. That number for pi, I'll show it right here, because although it's a long number, there are patterns in there. That's the other thing that's important to realize. There's a structure in there, so it's not just like a thin line where we have these little dots lining across like the universe. that there's a relationship there. Like I say, it's a grid. These things are generating energy and interacting with each other. There's a building up, and that building up is going to create patterns. And you can see here along the right-hand column, if you go from the top to the bottom, you can see there's a progression of numbers. And it's not simple though. It's interesting. You got extra numbers, but there is a progression from 1 to ABC, or to A and B, which is in base 12. Some of the numerals, and you get to 0. And that same pattern runs through all those columns, but in the other columns, it's staggered. It's every 5th or every 11th or every 8th and 7th numeral, and then you kind of go through a pattern. That same pattern emerges. So there's a lot of complexity in this version of pi. It's completely different from the base 10 version in that it has a real structure in there. There's patterns, and the question is, what do these numbers represent? Like, what do they actually, again, what's emerging? What do these numbers emerge from? And I really do believe it's this structure then generating more, building up. This is the inside of a proton. This is inside of protons, and then what's inside of the proton, and it goes to very small. So there's a lot of work to do here. Basically, instead of strings, we're talking about, I believe it's a torus. So this is, I guess, torus field theory would be the name of the theory that I've come up with, that's based on the geometry that emerges from base 12 geometry, or Dozenal geometry. All right, I think I've said enough for this video, giving you a lot of information. I hope you are feeling inspired to buy the book, start the conversation. If you have questions, please leave them for me. And other than that, I'm going to keep making these videos. So I hope to see you in the next video. Thanks for watching.